Today we're moving on to 392, which is 1 through 39 odd. So I'm going to solve a bunch of the even-numbered problems, and hopefully this brings back everything you learned last year, because this is all review. So turn to 392 and take a look at problem number 2. So problem number 2 says 169x equals 13. So there are two ways to solve this, and I don't care which way you use. One way is to convert to exponent, or convert from exponent to logarithm. So this would be log base 169 of 13 equals x. And then how do you evaluate that using the change of base formula? ln of 13 over ln of 169, and you're going to get 1/2, because the square root of 169 is 13. The way that I usually prefer to solve these is just ln both sides, and then you use the product rule to bring the x, or the power rule to bring the x down, and we get x ln of 169 is equal to the ln of 13, and then we divide by the ln of 169, and that will give you 1/2. So both ways work. You get to pick whatever version you like. Take a look at number 4. Same basic idea. ln both sides. So I can drop the x plus 1. So x plus 1 ln of 3/5 is equal to the ln of 25/9. So I'm going to divide by the ln of 3/5. So in my calculator, the ln of 25/9 divided by the ln of 3/5. Why does that number make sense? Could you have figured out -2 before? So 3/5 to what power is 25/9? Well, 5 squared is 25 and 3 squared is 9. So it's to the second power, but they flipped upside down, so it would need to be negative. So we're left with x plus 1 equals -2. Subtract 1, and x is -3. Okay, number 6. So we'll ln both sides. What is the ln of 1? 0. So we get x squared minus 1 times the ln of 10 equals 0. And if I divide the ln of 10, I still am left with 0. So x squared minus 1 equals 0. The roots of that would be plus or minus 1. It's a difference of perfect squares. It factors into x plus 1 and x minus 1. So the roots are plus or minus 1. Or you could add 1 and square root, and you still get plus or minus 1. Okay. Number 8. Okay, this one's a little bit harder. Notice we have variable exponents on both sides. So I'll ln both sides. X ln of 125 is equal to 2x minus 3 ln of 5. How would you move the x's together? Divide by. So I could divide by ln of, if I divide this way, 125 to what power is 5? Would be the 1/3. But if I divide the other way, 5 to what power is 125? the third. So I think I actually want to divide it this way, and I get 3x equals 2x minus 3. If you did it the other way, it's still going to work, but you're going to end up with 2x minus 3 times 1/3, and then you're going to want to times by 3 anyways. So I would prefer to move the ln to the left, and now it's just a simple algebra problem. Subtract the 2x, and we get x equals -3. That makes sense? Now that one ended up being easier than I thought it was going to be. Usually they're harder than that. So take a look at 10. So ln both sides, drop the exponents. X squared minus, oh, wait a minute. There's an easier way to do this. Ditch the 5s. The bases are the same. If the bases are the same, then we can just throw them out. And we're left with x squared minus 3 equals 2x, which is what we would get if we natural log both sides. ln 5 equals 2x ln 5. We divide by ln 5, and that turns into a 1. Now what? Subtract the 2x. So x squared minus 2x minus 3. What are the factors? X minus 3 and x plus 1. So x could be 3 or -1. Okay. All right, number 12. So we natural log both sides. X minus 1 ln 16 is equal to x squared ln 2. Which one do I want to divide? I want to divide by the ln of 2. So if I divide this by the ln of 2, 2 to what power is 16? 2 times 2 would be 4, times 2 would be 8, times 2 would be 16. So that's 2 to the 4th. So this is just a 4. So I get 4 times x minus 1 is equal to x squared. Distribute the 4. So 4x minus 4 equals x squared. Move everything to the right. Minus 4x plus 4. How does that factor? There are two numbers that multiply to be 2 and add to be -4. Or multiply to be 4 and add to be -4. -2 and -2. So it's x minus 2 squared. So this actually has one answer, +2. Okay. Number 13 might look difficult, but what's the easiest way to solve 13? Just delete the e's. We have the same base, so the exponents must be equal. Okay. So we're going to do the same thing in the next set, but now the answers aren't going to be so nice. So take a look at 16, and it tells you you need to solve the exponential equations exactly and then find the decimal approximate. What does exactly mean? So how, I mean, if it's a terrible decimal, how do you get the exact answer? Now, rounding it will be the approximate. If it is a fraction, you can write the fraction, but chances are these are irrational. You have to represent the answer as a logarithm. So what it's saying is, if you were to graph this and find the x-intercepts, they're going to be irrational numbers, and that's an approximation. But you also need to know the logarithm answer. And if they were to ask something like this on the final, they would say, give the exact answer, not the approximate. So if you put 6.53, that would be incorrect, but the ln of 48 over the ln of 5 is the correct answer, or something like that. So number 16, natural log both sides. So the natural log of 15 is equal to 3 minus 2x times the natural log of 7. Now what do I do? Divide the natural log of 7. So now this is gone. Do I want to calculate what this equals? Eventually, but it told me I need the exact answer, so I need to write the answer with the logarithms in it. Nope, not yet. I'm going to subtract 3. So ln of 15 over the ln of 7, subtract 3. That gets rid of this. And then divide the whole thing by negative 2. That is the exact answer. Now, the answer, Cynthia Young might somehow simplify that, but I wouldn't. The answer there is exact. That is an exact answer. Now, we could manipulate it to make it look nicer, but on a final test, that will count as an exact answer. If you try to simplify it and make a mistake, then I'll have to mark it wrong. So you'd want to leave it there, and then calculate the approximate. So the ln of 15 divided by the ln of 7, subtract 3, and then divide by negative 2. So 0.8 is the exact answer, or the approximate answer. Okay, I want to do one. Okay, let's do number 20. What would we do for 20? Subtract 21. So we get negative 4e to the 0.1 x is equal to negative 20, or sorry, negative 16. Then we divide negative 4. So e to the 0.1 x is equal to 4. Now we ln both sides, and we drop this. 0.1 x is equal, well, what is the ln of e? It's 1, so we get 1 times 0.1 x. So this is the natural log of 4, and I'm going to divide by 0.1. So that is the exact answer. ln of 4 divided by 0.1, and that is the approximate answer, 13.8. All right, we need to do at least one that looks like... Oh, they're not going to make us do... We owe Cynthia Young an apology. She kept some of the hard ones out of there. Okay, let's do... You can handle 27, you can handle 29. Look at 32. How are we going to solve 32? Thirty-two is kind of, it looks tough. It's actually easy to do. Well, if all we had were 2 base e's, then we could put one on one side and one on the other side and ln both sides. But I have a negative 5 in there, which messes it up. So this is a trinomial. We can't isolate both e's at the same time. And maybe there's a way to isolate one of them and natural log one side. And I don't think it would work, but even if it did, it would be a horrid mess. So this equation looks sort of similar to something we have a lot of practice with. It looks really similar to a quadratic, right? So we're going to do u substitution, which is something we did what, a couple months ago? So I want this to say u squared minus 4u minus 5. And in order for that to work, u has to be equal to what value? And it's always this value. It's always the variable portion of the middle term. So u would equal e to the x. So if I do u substitution, then how does this factor? U minus 5 and u plus 1. So u is either equal to 5 or u is equal to negative 1. But u is equivalent to e to the x. So that gives me e to the x equals 5 and e to the x equals negative 1. Well, what do you know about this? E is a positive number. How many times can you multiply a positive number together to get a negative number? It will never happen. So even if you tried to solve this, you would get the ln of negative 1, which doesn't exist. So your calculator would give you error. So this one only has one solution. We natural log both sides. X ln of e is equal to the ln of 5. The ln of e is 1. So my answer is the ln of 5. That's the exact answer. The approximate answer is going to be 1.6. So let's do one more of those. Oh, I don't have one more to do. You can do 31, it's easy. Oh, wait a minute. Well, let's do 31. So, using u substitution, u squared plus 7u minus 3, where u is equal to e to the x. Are there factors of 3 that add to be 7? No. The biggest we can make that is 4. Well, it's a subtraction, so the biggest we can make it is negative 2. Okay, so we need to use the quadratic formula. Does this have real roots? Do I even want to bother? How do I know it has real roots? Well, it's a positive quadratic, and it has a y-intercept of negative 3. So it hits the y-axis at negative 3, and it opens up, so it has to hit somewhere. We just don't know where yet. So let's plug this into the quadratic formula. Negative 7 plus or minus the square root of 49 minus 4 times 1 times negative 3. That's going to be 12 over 2. So 7 plus or minus, that's going to be 61. Oh, thank you, Cynthia, for doing this to us. Negative 7, thank you. Okay. So that is equal to e to the x. Well, one of them is negative. Negative 7 minus the square root of 61 is negative. What about the other one? Negative 7 plus the square root of 61. Is the square root of 61 bigger than or smaller than 7? Bigger than 7. So the second one actually is positive. So we can go in and get rid of this. So we ln both sides and drop the x, and ln of e goes away. So it's the natural log of negative 7 plus the square root of 61 over 2. Somebody double check the answer and make sure that's right. And then whatever the equivalent decimal is, you can type that in your calculator. Cynthia Young. Who is she anyway? Who does she think she is? All right. 34. Is it bad? Is the stuff I wrote better than the stuff she wrote? Why didn't I write the book? Because I wrote everything you did last year and the year before. All right. 34 is kind of tricky. We have 3x minus 3 to the negative x multiplied by 3x plus 3 to the negative x. What would you do here? Well, we might as well multiply them together and see what happens. The nice thing is, these are conjugates. Conjugates mean you have two binomials where the term in the middle is different. Otherwise, they're identical. Why are conjugates nice? The middle terms always cancel, and we can just square the first. So first times first and last times last, and ignore everything in between. So what is 3x times 3 to the x times 3 to the x? So if I had x squared times x squared, that would equal x to the fourth. So the bases don't change, but the exponents add together. Bases don't change, but the exponents add together. So 3 to the x times 3 to the x is 3 to the x plus x, or 2x. And then minus, what is this one times itself? 3 to the negative 2x equals 0. Now what? Move 1 to the other side. So I'm going to get this. So well, we don't want to divide by 3. I can drop the bases. Bases are the same. So when does 2x equal negative 2x? If x was negative 1, I'd plug negative 1 in there and I'd get negative 2. And I'd plug negative 1 in there and I would get 2, which is not equal. No? Well, don't forget your rules of algebra. We're going to add 2x to the other side. 2x plus 2x equals 0. 4x equals 0. The only answer for that would be 0. I was hoping somebody would see it right here. This is just 1 over 3 to the 2x. So when does 3 to the 2x equal 1 over 3 to the 2x? The only way to make that work is to get 1 over 1 equals 1 over 1. And 0 is the only answer that will make that work. So that one was kind of tough. Okay, 36. What would you do for 36? You can only natural log both sides once you've isolated the e to the x. So we're going to multiply e to the x plus 4 to the other side. Now, we have to make sure that the bottom is never 0. So that's something to think about. When you move a variable off the bottom, you have to make sure that it's never 0. But can e to the x ever equal negative 4? No, so we don't have to worry about it. Okay, now what? Divide by 2. 17 over 2 is equal to e to the x plus 4. Subtract 4. So 17 over 2 minus 8 over 4. Or wait, 8 over 2. So 9 over 2 equals e to the x. And you just natural log both sides. Too easy. Okay. Good luck.